Today, we're going to talk about the invisible forces that are, well, basically running your entire world. We're talking about physics, but not as some scary, complicated subject. Think of it more like the operating system that's just humming along in the background of everything you do. So, when you hear the word physics, what's the first thing that pops into your head? Is it a dusty blackboard just filled with impossible equations? Yeah, for a lot of people it is. But what if I told you that's not even close to the whole story? Because the truth is, you're a natural physicist. You really are. I mean, from the second you woke up this morning, you've been using physics principles over and over again, and you probably didn't even notice. So let's walk through it. Okay, let's start at the very beginning of your day. You know that whole morning routine you do pretty much on autopilot? Turns out, it's just a masterclass in physics, from the buzz of your alarm to the coffee you're making. Think about that sound that dragged you out of bed this morning. It's a perfect example. If you have an old school alarm clock, when you wind it, you're storing up potential energy in that coiled spring. Then, as it unwinds, all that stored potential energy becomes kinetic energy, the energy of motion. And that is what drives the clock and makes a little hammer vibrate, creating the sound waves that jolt you awake. It's all just energy conversion. And what about just walking across the room? You wouldn't believe how much physics is going on. You've got friction, which gives your shoes the grip to not slip. You've got gravity, holding you down, giving you the weight you need for that friction to work. And with every single step, you push back on the planet Earth, and thanks to Newton's third law, the Earth pushes you forward. It's this incredible dance of multiple forces just to take one step. And making breakfast? That's just one big lesson in thermodynamics. First, heat moves directly from the burner into the pan. That's called conduction. Then, if you're boiling water, the molecules at the bottom get hot, they get less dense, and they start to rise. At the same time, the cooler water on top sinks down to take its place. This whole cycle is called convection, and it's how heat moves through liquids and gases. Okay, now let's talk about your commute. It doesn't matter if you're in a car, on a bus, or just walking. Your whole journey is basically dictated by three beautifully simple laws of motion that Isaac Newton figured out centuries ago. First up, we've got the law of inertia. All it really means is that things, well, they like to keep doing whatever it is they're already doing. A book on a table is going to stay on that table forever unless you or something else gives it a push. That resistance to change, that's inertia. And you feel this one in a big way when you're in a car, right? If the driver slams on the brakes, the car stops, but your body wants to keep going forward because of its own inertia. And that is exactly why seatbelts are so important. They provide that outside force that stops you right along with the car. It's literally a life-saving application of physics. Newton's second law is where we get that famous equation. Force equals mass times acceleration, or F equals ma. And it's just this incredibly elegant relationship. If you want something to speed up, to accelerate, you have to apply a force. Simple. And the more stuff an object has, the more mass, the more force you're going to need to get it moving. You know this one intuitively. Think about pushing a shopping cart. An empty one? Easy, it's a breeze. But a full one? Whoa. You've got to push way harder to get it going at the same speed. Same thing with a football. The harder you kick it, the more force you apply, the faster it's going to accelerate. That's F equals ma, right there in the grocery store aisle. Now, Newton's third law, this one is almost like poetry. For every single action, there is an equal and opposite reaction. What that really means is that forces never happen by themselves. They always come in pairs. And we see this everywhere. A rocket pushes hot gas down, and that exhaust gas pushes the rocket up. When you swim, you push the water backward with your hands, and the water pushes you forward. And yeah, just like we talked about earlier, when you walk, you push the ground backward with your foot, and the ground pushes you forward. Action, reaction. It's that simple, and it's absolutely everywhere. All right, so let's uncover some of the physics that are kind of hiding in plain sight in all the objects we use every day. We're talking about everything from a simple door handle to the phone in your pocket. Now, here's something people mix up all the time: mass versus weight. So what's the deal? Well, your mass is the amount of stuff you're made of. It's constant no matter where you go. Your weight, though, that's the force of gravity pulling on all that stuff. It's a force, and it can change depending on where you are. So let's make this real. Let's say your mass is 60 kilograms. Here on Earth, your weight is about 588 newtons. But if you took a trip to the moon, where gravity is way weaker, your weight would only be 96 newtons. Your mass, the amount of you, is exactly the same, but your weight has changed like crazy. That's why astronauts can bounce around up there. Ever stop to think about why door handles are always on the opposite side from the hinges? The answer is a cool concept called torque. Torque is basically a rotational force. And by putting the handle far away from the hinge, you get more leverage so you can swing a big, heavy door with just a tiny little push. It's physics making your life easier. And what about that device you're probably holding right now? Your phone is an absolute marvel of physics. It's using the principles of electromagnetism to send and receive signals through the air, and it's powered by incredibly complex electrical circuits. It is, for all intents and purposes, a pocket-sized physics lab. Okay, now for the really fun part. You do not need a fancy laboratory to see this stuff in action. Your own kitchen is actually full of opportunities for some cool discoveries. Let's try a couple of super simple experiments you can do right now. First up, let's make some raisins dance. Seriously, just drop a few raisins into a glass of any fizzy drink. At first, they'll sink right to the bottom, but then watch closely. You'll see tiny bubbles of carbon dioxide start clinging to their wrinkly surface, acting like little life preservers. Pretty soon, the raisins will float up to the top, the bubbles will pop, and they'll sink back down again. It's this awesome little dance, and it's all powered by buoyancy. Okay, next up, we're gonna make something called a Cartesian diver. Find one of those little ketchup packets that just barely floats and put it in a plastic bottle that's full of water and sealed tight. Now squeeze the bottle. Squeeze it hard. The pressure you're adding compresses a tiny air bubble inside the packet, which makes it denser than the water, and it dives to the bottom. Then let go, the pressure releases, and it floats right back up. You just built a simple submarine. So, after seeing all of this, what's the big takeaway? Really, it's all about shifting your perspective just a little bit to see the hidden rules that are running our world all the time. I think this idea sums it up just perfectly. Physics isn't something that's locked away in a textbook. It's happening right here, right now, all around you. And if you have just a little bit of curiosity, your kitchen turns into a laboratory, and even a simple walk becomes a cool experiment. Once you start looking, you see that physics gives you this whole new lens to see the world through. So now that you've started to see that invisible operating system that's running in the background of your life, the only real question left is, what are you going to investigate next?